Hello friends, good evening. In my today's lecture, I will be talking about properties of the matter and their measurements. In chemistry, we told you that we are studying the properties of the matter, which are of two types, physical properties and chemical properties. Many of the properties which we study are quantitative in nature. That means we can measure these values by some instrument and they follow and obey certain laws of the science. These quantities are known as physical quantities. Physical quantities. Those quantities which we can measure by an instrument and have got a value. Now the question is, what are these physical quantities? Here on the board I have already written that length, mass, time, amount, temperature, force, pressure. These are all examples of physical quantities which we are measuring. For example, if I am measuring length, then how will we measure length? For example, if we want to measure length, we have used different types of units for the measurement of the length. If I write a number 5, it is incomplete and it has no meaning. But if I write 5 meter, this means that there is a value 5 and meter. Meter is the unit of the measurement which I have done for the length. Someone can say 50 centimeter. Again I am saying 50 is a numerical number and centimeter is a unit of the length. You have found many units like miles, kilometer. These are all the units which we have been using for the length. If I consider another physical quantity which I am saying is mass. Mass is another physical quantity, and when we measure the mass, you know that mass of a substance is the amount of the matter contained in a body, whereas weight is m into g. Here we are saying if we measure the mass of the substance, if I write 5 kg, that means kg is the unit in which I have done the measurement and 5 is a number. Or in other words, I can express any physical quantity in two things. Q is my physical quantity. I am representing a number and a unit. So any physical quantity can be expressed as a product of a value and a unit. Or in other words, we will always do the measurement by using some reference, by using some standard in order to measure our physical quantity, and that is what we call as a unit. But the unit should have a standard value. Here I said my unit is a meter, here my unit is a centimeter, here my unit is a mile. These values are standard values. They have been accepted everywhere. The value of the units should be such that it should not change. Therefore, for the measurement of any physical quantities or any quantity in physics, in chemistry, in science or in engineering, we are using different type of system of units. You are aware that in mass I have shown you kilogram, somewhere people are using pounds, and all these units have been used. And when we talk of time, you have seen for the measurement of the time, which is also a physical quantity, we are using seconds, hours, days. And for temperature also, if I want to measure the degree of hotness or the degree of the coldness of an object, I can use temperature. And you know that man has used different type of scales for the temperature, for the units which we have been using Kelvin, we have been using centigrade or Celsius, we have been using Fahrenheit. And when I talk of current, you can see that this is also a physical quantity. Here I have shown a unit ampere. Now, what we want to tell you that different units have been used by man for the measurement. Supposing I am standing in a room, then if I want to do the measurement of the room, I can say that what is the length of the room, what is the breadth of the room, what is the height of the room. We can give it in meters, we can give in centimeters, or we can give in different type of units. But the problem is that if we will keep on using different units which the man has been using from old times, there will be a lot of problem because we will have to convert one form of unit into another form of the unit. units. The history of the measurement, if we study a little bit about the history of the measurement, we will find that in old times, man did not have any instruments, did not have any apparatus or any equipment to measure these type of the measurements which he wanted to do. And you will see that in old times, they have used the body parts to do the measurements. The hand of the kings have been used, the foot has been used. That is how it became foot, pound. So the question is today that what type of units we should use so that they are internationally accepted. We are aware of the fact that two things I told you, that there is a physical quantity, then I told you there are units, and the system of units. We are aware that two system of units have been very commonly used. In the books you will find this is foot, pound, second, and this I am saying centimeter, grams, seconds. These two system of units have been used very commonly by the man. And you will find that FPS system, British system has been used, and also CGS system has been used after the French Revolution. You will find that this system is known as a metric system. This was more important than this. And one more system you will find is MKS, which has meter, kilogram, second. From the French 1971 onwards, MK system became very important, and from the MK system was born the SI system of units. SI means Standard International System of Unit, which has been accepted internationally, and today we are using SI system. And the most important thing about SI system is there are 7 basic or 7 fundamental base units which are existing in this SI base units, and these 7 base units are very important because from these 7 base units we can derive all other physical quantities or the units of all other physical quantities. So that makes the life very easy for us. At the same time, if we will be using different type of units, there can be a lot of confusion and there can be serious difficulties and problems. In the history, when while studying about the units and measurement, I found there have been serious accidents of air crashes because of the problem of the units. Because when you go from one country to another country, if the units used are different and if some information is there which we cannot communicate or give information in different units, there could be a problem and confusion. Therefore, today we are very clear that we will be using, and we have an international accepted unit which I am talking about, SI unit, as international units. There are 7 fundamental base quantities which have been listed in SI units, and you can see that in SI unit the first quantity we are talking of length. Length is measured in meter and is represented by a small m. The next is mass. Mass is always measured in kilograms. In SI unit of mass is kilogram, represented by kg. SI unit of time is second, represented by s. SI unit of amount. Amount is the mole, which is MOL, this is a symbol of that, and SI unit of temperature is Kelvin, SI unit of electric current is ampere, and SI unit of luminous intensity is candela, represented by CD. As you can see that there some letters are small and few letters are shown in the capital letters, and it is a practice in science or in physics or in chemistry. Wherever a scale has been developed by a scientist, the name of the scientist is represented by capital letter. So Kelvin is the name of the scientist, ampere is the name of the scientist, so these letters are big ones. Therefore, there are 7 fundamental basic units to us. This is the system SI unit which is internationally accepted, and from this 7 units we can derive other physical quantities and the units of other physical quantities. For example, what I have said that we have 7 base units. So units have been defined in two forms. One are the base unit or 7 fundamental units, and second are the derived units. Base units 7. Second, I am talking that we have derived units. Units which can be derived from this. For example, the speed of your car, if I talk the speed of the car is kilometers per hour, or in SI unit the speed of the car is distance by time. That means the SI unit of distance, which is length, is meter, for time it is second. That means I can represent it like F minus T. Therefore, I can derive the SI unit of speed by using the base units. This comes to be meter per second in the SI. Similarly, if I take momentum is mass into velocity. So the SI unit of mass I am saying is kg, and velocity is meter per second, kg meter S inverse. So we can derive the units from the fundamental units. They are called derived units. The important thing is that if I consider length has no relation with the mass. I cannot add length in mass because they are two different properties. They are independent of each other. They are not dependent. Similarly, length and time, I cannot add length in time because they are two different fundamental units. There is no relation between length and time. Similarly, there is no relation between length and amount. There is no relation between length and time. Each unit is independent and cannot be expressed in the same physical quantity, which we have listed as 7 fundamental quantities. But here what we are seeing that, for example, if I take pressure, I am saying pressure is force per unit area. And force you are saying is a mass into acceleration divided by area. So you have kilogram, you have meter per second square, and here you have area which you are saying is meter square. So what it becomes? Kilogram meter S square meter square. So you can cancel this. So you can get kilogram M inverse S minus 2. So we can express these units in this form which we are talking. So this, what we are saying, that here we are talking of force per unit area, which is the pressure. This is a unit which can be derived from the fundamental quantities. And you will find that certain units, when we derive, they become so big, and they have also been given SI names. For example, force, if I write M into A, you are saying is kilogram meter mass into acceleration. Mass is kilogram meter per second square, which comes to be kg n s minus 2. This is the unit of this. This has been given the name Newton, represented by n in SI unit. As you will see, force Newton 1 meter kilogram S, and the pressure have been given an SI unit name as Pascal. Celsius degree is also being used a lot, but it can be obtained from Kelvin scale by this formula, Kelvin minus 273.5. And for energy, we have derived a unit from the fundamental quantities, which is known as the joule. Joule is an accepted unit of energy. SI unit of energy is joule. For power, the SI unit is watt. For frequency, it is seconds inverse or hertz. For electric charge, which is 1 coulomb, is 1 ampere second. Electric potential 1 volt is 1 joule per coulomb. Therefore, what we have tried to show here, that there are 7 base units which have been given in your book, which are internationally accepted. These units have been defined in your book, in your NCERT book. You will find a definition of these units have been given, and these values are well defined, and they are present from in the France. It is available, 1 kilogram, etc. Standards are available. They have been clearly defined. In addition to the 7 base units, it was found that 2 more supplementary units are required. For example, if we want to measure an angle between the two lines, then we are using radians. And if we have an angle between a cone or three-dimensional, then we are talking of steradian. So those two supplementary units have been added in these 7 base units, but those two supplementary units are dimensionless. They have no dimensions of their own. But here we are giving, we can express, we can define, we can give the dimensions of these derived units in terms of the 7 base units. This was a very good part because these units are now internationally accepted. Therefore, we can use kilogram, we can use meter, we can use 7, and only 7 are required. But out of the 7, you will see that a man used MT a lot. And amount. In chemistry, we will be using length, mass, time, amount, and temperature. These first five will be of great use in chemistry, as you will be measuring pressure, you will be measuring the volume. In all these measurements, length, mass, time, amount, temperature, they will be in great use. In electrochemistry, electric current will be used. In physics, you are using luminous intensity also, and 2 supplementary units also. Then derived units, you can see that chemistry, we are talking of pressure, we are talking of volume, you are talking of temperature in the Kelvin scale, and Kelvin scale can be converted into the Celsius scale also. Frequency also we are using. All these will become important when we will consider the units in the chemistry. But in science, what is happening in physics, in chemistry, or in science, what type of numbers you are dealing? What type of numbers you are seeing? One good advantage of the 7 SI unit is that these units, or the units which we have made, they should be reproducible, they should be coherent, they should be rational, they should not change, the value should not change with time. And one important system is that this is a metric system. What do you mean by a metric system? This is the advantage of the SI system of units. That means we can multiply with the powers of 10 or divide with the powers of 10 to get the values. What is the reason for that? Because in science, in physics, in chemistry, what type of numbers you are dealing with? If I talk of the radius of an atom, you are talking, say, 1 angstrom, which is 10 minus 10 meter. It is not the number which we are dealing in everyday life, 1 meter, 2 meter, 3 meter. I am talking of a number 10 minus 10 meter. And if I talk atomic mass unit, or 1U, which is a mass of 1/12 the mass of carbon 12 isotope, which is around 1, which is, I am saying, 1.66 into 10 minus 24 gram, or 1.66 into 10 minus 27 kg. If I talk of the Avogadro's number in chemistry, which you use a lot, Avogadro's number, now you are talking of 6.022 into 10 power 23 atoms, molecules or particles. If I talk the mass of the electron, you are talking of a number 10 minus 30 kg. If I talk the velocity of the light, you are saying 3 into 10 power 8 meters per second. If I talk of the mass of the universe, you are saying this is of the order of 10 power 50 kg, mass of universe. 10 power plus 50 kg. Here is a problem that you are dealing with numbers which are very, very small fractions of 10, 10, 10, or 6.02, 10 power 23, or 10 minus 24, 10 minus 27 kg. How will we write these numbers? Now, this is a problem, scientific problem now. If I write on a blackboard 20 zeros, it will fill my complete blackboard. If I consider another unit Ly, the distance traveled by the light in 1 year, it is coming 9.5 into 10 power 15 meters. So the number is, if I write 10 power 15, 10, 15, 0 on the blackboard, it will fill it completely. Therefore, if I talk of AU, astronomical unit, distance between Earth and Sun, it is around, supposing 1.5 into 10 power 11 meter. Then I say radius of the nucleus. You are saying radius of the nucleus is around 10 minus 15 meter. Which are talking of 1 Fermi. 10 minus 15 meter. Radius of the atom, you are talking of the radius of the atom. You are saying it is 10 minus 10 meter of the order of this. What type of numbers are these? We are now dealing with very small numbers and very large numbers in science, in engineering, and therefore these numbers or the units which are chosen, 1 meter unit which are chosen, may not be very convenient and comfortable to handle such numbers. It will be difficult if I use 1 meter to measure such distances. Therefore, these units have been defined, they are standard, but there is a need of something more than that. And as I said, it is a metric system, therefore it is possible to use multiples of 10 or divide by multiples of 10 in order to get a number. That is why SI prefix have been given. There are 20 SI prefixes. There are 20 SI prefixes which have been given. So if I put these numbers before them, then my calculation part and my writing part and my scientific calculations will become very easy and workable. Therefore, we have SI prefixes. Pre means before. We will write these numbers. Let us see what we are talking about. Here we have, supposing I begin with data. Data is a very convenient number 10. We are all aware of that. Now I put power of 2 on this, it becomes hecto, which I represent by small h. 10 power 3 is a kilo k. If I say kilogram means 10 power 3 gram. If I write mega, you are saying there is a mega event, means there will be 10 power 6 people into that event. That means 10 power 6 mega. Symbol is M. After this, I add another 10 power 3 giga. You have heard about gigabytes nowadays. Then I am talking of tera, which is 10 power 12, peta is 10 power 15, exa 10 power 80, zeta and jota. So these are the prefixes which we can apply in the SI units to make these numbers more convenient. Therefore, these numbers are increasing, you can see these are mostly capital letters because the powers of 10 positive, positive, positive. As I go down now, what we see that I am talking from deca to deci. Deci is 10 minus 1, centi is 10 minus 2, milli. I use a lot of milligram. When I say milligram, milligram means 10 minus 3 of a gram. Then I say microgram. Microgram means 10 minus 6 of a gram. Someone says nanogram. So for a nanogram I am using 10 minus 9 of a gram. Picometer. Picometer means, as you can see, it is 10 minus 12 of a meter. So it becomes an easy representation in order. Instead of writing so many zeros or 10, I can start writing milligram, microgram, nanogram, hectometer, kilograms, megahertz, gigabytes, tera. All these numbers becomes makes our calculation and writing part more convenient and comfortable. So this is another advantage, that the 7 base units which we have given, there are 2 supplementary units I told you, also for the angles, for the angle between 2 lines and the angle between a cone, 3-dimensional cones, radian and steradian. But these units, we can use these prefixes in order to make our calculation, which are scientific calculations, because in science, in physics and chemistry, we will be dealing with such numbers as we will see in our calculations. In chemistry, what we will be studying mostly, in chemistry, what type of physical quantities we are measuring. In chemistry, what physical quantities you are measuring? You are measuring pressure. Pressure you said is force per unit area. Here you have defined the SI unit of pressure as Pascal, which is 1 Newton per meter square. This will be used a lot in chemistry. Then you are using volume. In chemistry lab, you have seen that you are doing large number of volume measurements. Normally you use a unit which is liter. Liter is not a SI unit, but it has been very commonly used, and you should know that 1 liter is equal to 1000 milliliter, or in other words, if I take a cube of 10 centimeter, it has been defined that 1 liter is equal to 10 centimeter the cube now, which is equal to 10 power 3 centimeter cube. So we can express liter in centimeter cube, and we can express centimeter cube into decimeter cube, which will be equal to 1 decimeter cube, or which will be equal to 10 minus 3 meter cube. Therefore, we can express the unit of volume in different units, but SI unit is always, SI unit you will see for is meter, and for volume, which is a derived unit, meter into meter into meter is meter cube. Hence, these pressure will be measured in chemistry, volume will be measured, and we will be doing the measurement of mass measurement. So most of the time kg is SI unit, but these units will help us a lot because the numbers which we are dealing, mass of the electron, mass of the proton, mass of the neutron, or mass radius of the atom, all these numbers, therefore this will become important. SI prefixes will be used by us in these type of calculations. Therefore now what we have defined to you in this lecture, that what are units, what are physical quantities, and what are the SI units. Why there was a need for the international standard units, because there will be confusion and there will be a lot of problems and cheating if we don't have standard system of units. Therefore, today we have 7 base units, and from these 7 base units we can derive all other physical quantities which we need: volume, pressure, temperature, which we are saying is in Kelvin scale, but it has been expressed in Celsius also, and physics also. We can derive the power, we can derive energy, we can derive electric charge, frequency, electric potential from these 7 base units which we have. So in this lecture we have used SI units, derived units, and SI prefixes in order to make our calculation and scientific part more convenient and comfortable, depending on the size of the dimensions which we are using in science, from 10 power 23 to 10 minus 23 and all these type of numbers. And I think in this lecture we are stopping here. In my next lecture I will talk of dimensions, and will try to convert, show you how we can convert physical quantities from one system of unit into another system of units, which is a very important thing, because in physics or in chemistry, in your exams there will be large number of calculations, numericals, in which we will have to convert one system of unit into another system of units. So with the knowledge of these units it is possible, because most of the times we have 7 base fundamental units which we have said, and we can derive all other units. Therefore, in my next lecture, wait and see, I will try to solve some questions from your books also, in which I will show you that how we can convert one system of unit into another system of unit. I thank you a lot. I hope that this served your purpose, and since the exams are coming, I would like to see that my next lecture will be very important in units and measurements, and we are all doing units and measurement in our everyday life, and all physical quantities we are measuring, and therefore I hope that you will be waiting for my next lecture, and I thank you again. Keep working hard, and we'll see you next time in the next lecture. Thank you.